Welcome, ladies and gentlemen, and here we are to do some homework take-up, and I am first and foremost very, very, very happy with what's happening with my studio audience, because it seems that they have been working together and they got a group chat and they've all been commiserating over the homework, and that is awesome, and you should be doing that. I'm putting on a new mask here. My old masks were really, really great, but they bought me new masks. Look, I have new masks that I can wear. They look the same, but they're not. See, this part is not as stretchy, and what's going to happen? Look and this isn't as big. Look, I look like Dumbo. Here. It makes my ears come out. I got ears coming out. It's pushing my ears around. It's not. I look like my daughter. She has big ears. Okay, so moving on. So homework take up. All right. What do you want to know? What's bothering you? I'm throwing it out to the studio audience. There goes the hands. Yes, you. 8E. Couldn't. Yeah, I don't care. Read me the question.
It was lim approach as x approaches 4.
Okay, I can't let that go. It is the limit as x approaches 4. There is no lim, child. Okay, go, keep going.
The limit as x approaches 4. Wait, I forgot how to say it. It's square root x minus 2 over square root x3 minus 8.
The minus 8 and the minus 2 aren't part of the root.
Yeah, sorry. I said it really weird.
And so, and I'm letting this happen, and I'm recording this because I want you guys to learn that you need to be able to speak about mathematics. So, did you notice the way she started talking to me about, I came up with this, but I think this is what we meant, am I right?
Yeah.
So, this is part of what I need to teach you. I know this. I know you guys can't read your math. We need to talk about how to read it. So this is the limit as x approaches 4. My ears are really sticking out with this. Oh, it broke! Look! My ear broke the darn thing. Oh, I'm putting in a formal complaint. That's it. Who do I talk to? Doug? Good old Doug. And which way do they go even? I think they go this way. Blue side out?
Yeah.
Oh, how do you know that?
Because
She works at a grocery store. Oh, I'm not sure how that went. Look, my ear, it's better. All right. So here I am again. So this is how we say it. The limit as x approaches 4 of the square root of x, period. Take a breath. Subtract 2. See how I did that?
Yeah.
The square root of x, subtract 2. All over the square root of x cubed, or if that's outside, you say the square root of x to the 3. Take a breath. Subtract 8. So let's watch that one more time. The limit as x approaches 4 of the root of x, subtract 2, all over the root of x cubed minus 8. Okay, so now we want to do this question. Okay. She was using substitution, so now she's even going to tell me which I have to use. Okay, does it say, yes, 8 says you have to use substitution. Okay, so which part is the, I don't like using this word, but I'm going to use it. Which part is the ugly part? None of it's ugly, please understand this, but there is a part of it that probably makes you feel uncomfortable, and this is the part that makes you feel uncomfortable, I'm pretty sure of it. So we're going to say let u equal u cubed square root. No, we're not, because that doesn't work. We're going to say let u equals x cubed square root. That's better. Okay. I'm still really upset with this mask. It's going to bother me all day. Okay, so that's great. So I could go around and I could substitute that for a u, but then I'd have root x's up. So I got to do something with that. So we need to find out what root x equals. And to do that, what I think I'll do, now, I wonder how quickly you guys can see that. Now that's left over from grade 11. You should know that. You should know that if I take x to the a over b, that could be written as, what did I do, an x 1 over b to the a, and that can be written as x to the a 1 over b. Is that showing up at all? There it is. So yeah, so I'm having some fun there with my exponents, and I'm just moving them around. And you really should be good at that. Let's look at a numerical example. So if I had 2 over 3, that's the same as 2 times 1/3, which is the same as 1/3 times 2. Now this isn't to the exponent because this is different rules, but this is really what I'm using here, right? I'm taking the idea of this fraction and breaking it up into two things being multiplied. Remember, that's 2 over 1, so it's going to be top times top, bottom times bottom. So anyway, back to here. I've got the x cubed to the exponent 1/2 is another way to think about that. And so what I'm going to do is I'm going to interchange the order of these, because the order of multiplication doesn't matter. And I'm going to put the 1/2 inside and put the cubed on the outside. And so that's going to give me this, because the 1/2 is the square root, which means that I can take the cubed root of both sides, which now gets me to the cubed root of 3, or u, sorry, is going to be root x. And is that making life any easier? I'm not sure. Let me take a look. So that's going to become this. That doesn't really make life much easier. Good. It doesn't make life. So now it makes me think. It's not really making life easier, but so maybe I did a bad substitution. What if I let my substitution be this? So that means that this will change to a u, but using the same argument here, this can change. Let me rewrite this. This one could change to, and that is more interesting because this will become, let u equals root 3. Therefore, I don't really need an x. I don't need to know what x is because look, if this is, that's going to be changed to a u. That's going to be changed to a u cubed. So now what I got to worry about is what happens when x approaches 4. So as x approaches 4, u is actually going to approach 2, because I put in the 4 here, right? So now I can change that. So look what I get. I get the limit as u approaches 2 of u minus 2 over top of u cubed minus 8. And that is a much easier looking problem, isn't it? Because I have gotten rid of the square roots. And now I just do it as a difference of cubes here. So this becomes the limit as u approaches 2 of u minus 2 on top, u minus 2, u squared plus 2u plus 4, which you should have learned by now. Notice I'm extending that bracket across. My 0 term is now here. I get rid of that. I put in 2, so I'm going to get 4, 4, and 4. So last time I checked, that's going to be 12. So it's 1 over 12. And remember, I activated the limit, ring, which means once I activate the limit, you do not write it out anymore because it's done. Okay? And my equal sign. Now, that was a great question. And I really like the fact that you had to see me work through it. And I really like the fact that you saw that what we were so used to doing all the time didn't work. And I had to stop and think about it. So, and my clue was I knew that I was looking at a difference of cubes here. My clue came to me when I realized I could do this. Because I had a root x on the bottom and I had a root x on the top. And that's when I realized I should be looking to substitute the root x for a u to make it look pretty. Now, that all being said, you can pause this video and take a picture of it if you want. I want to look at the exact same question just from a different standpoint. Now, question 8 said that you had to use substitution. So that's why I did it that way. Except let's look at a nice clean way of doing this. Same question. Knowing a little bit more of what I'm doing here. Are we all good with that? Like that's now after making all that messy stuff and whatever, you should be able to see how I can do that real quick, right? And so notice what I have here. This is a difference of cubes. Notice what I have here. So actually, I can use this as a difference of cubes, factoring. This can simply be root x minus 2, bracket root x squared, which is x, plus 2 root x, and then plus 4. And what I've made use of here is that idea of a difference of cubes, factoring, oops, that's an a and a b, plus b squared. So that's the rule. The only difference is It's root x cubed minus 2 cubed is what I'm using here. And it's that old idea that we talked about yesterday about difference of squares factoring. Remember, we kind of lied to you. We kind of told you that could be factored. And we kind of lied to you and told you that couldn't be factored. And, well, yeah, that's just a big, bold lie. It most certainly can. The fact is, it's just not a nice whole number. That's all. Okay? Pause the video there and maybe come back with another question.